This is Ahmed Abul Khair from Data Valley Technologies, and today we will demonstrate support vector machines or SVM, a very popular machine learning algorithm. First, support vector machine belongs to the supervised learning algorithms family. In this family, we have two groups of data, our training data and our testing data. For the training data, they will be used in deducing our parameters for the algorithm, and the testing group will be used in validation. Support vector machine is very popular and can be used in many domains like text categorization or image classification. It can be used in handwriting recognition as well. So what is the main idea of support vector machines? Suppose we have two groups of data, triangle points data and circle points data, and we will try to find a separator between these two groups. As we can see, these two groups can be perfectly separated by a line, so we can call these data a linearly separated data or linearly separable data. As we see on the graph on the right, in some cases we will have non-linear separated data. In this case, we will not be able to find a line that can be perfectly fit our data and separate our data into two groups perfectly. Unlike the scene on the left, we can find a line easily that can separate our data into two groups. So what is the main idea of SVM here? SVM is trying to transform our data from their original state in the XY plane, for example, and try to come up with another form, another shape of our data in another dimension like the XZ plane. So these points can be transformed to the XZ plane, and hence we can find a line that can separate our data perfectly. Here we are. Now we can separate between our triangle points and our circle points using Hyperplane Align, and this line can separate our data perfectly. Although we cannot find this line in the XY plane, we are now able to find this line in the XZ plane. So the main idea of SVM is transforming our data into a new form or a new shape. But will our line will be perfect for all cases? Suppose we have the case on the right, we have now a line that cannot separate our data perfectly. You can see that we have 2 points that are misclassified as triangle points, and the real state of these points is that they are circle points. So what is the solution here? So SVM proposed to come up with a different separator, which is not line at all. It may be a hyperplane, a completely separated plane that can separate our data and suit every point in our data. So when using support vector machines, we will be dealing with 4 hyperparameters that can control the performance of our algorithm. These parameters are our margin, kernel, regularization parameter, and gamma. Margin is the distance between our hyperplane, our separator, and the closest points to this line. So if this is our hyperplane, the margin will be these 2 dashed lines, and the distance between these 2 lines and our separator is called our margin, and we can call these 2 dashed lines support vectors. Support because they support our selection of this hyperplane. How can we tune this parameter in Python implementation? Scalar, we can use C parameter, if this is our hyperplane and this point will be misclassified, that's because we are using some hyperparameter C that we can tune in like this way in this slide. If we used margin C in a small value of C, we have higher regularization effect. If we have high value of C, we will have lower regularization effect. So here we are minimizing our margin. That's mean that we have now a line that can fit every data point in our training, which may not be good all the time. So in this case we have a very tight margin. Unlike this case, we have a relatively big margin, hence we have less regularization effect. Less regularization effect means that our training can generalize better for new points, and we will come up with these points in the future slides. Gamma is another important hyperparameter that can control the data points that contribute in selection of this hyperplane. For low gamma, we are letting the farthest points to contribute in our selection of this hyperparameter. You can see that the farthest points here are contributing more in selection of this hyperparameter. Unlike high gamma, we are letting the closest points to contribute more in selection of this hyperplane or separation line. Kernel. Kernel is the equation or the mathematical function that will transform our data from its original state to another state that may let our data to be separated by a line or a hyperplane. So we have too many kernel functions that we can use. We can use linear kernels, we can use nonlinear kernels, we can use sigmoid, polynomial, exponential, and RBF. RBF is a very famous kernel function. So kernel function is trying to find a shape of our data, XY data, that is constructed from our X data separately multiplied by our Y data, and this way we can find a new form or a new shape of our data. What is the pros and cons of using SVM this way? SVM works well with clear margin of separation. So if you have some data points that can separated by a good margin, a good distance between the two classes or the two categories you are trying to classify, hence SVM will be perfect choice. If you have high dimensional data, which means number of columns will be higher than the number of rows, here SVM will be perfect because this dimensionality will help our SVM to find a new form, a new good form of our data that can be separated easily. Again, it's effective in cases where number of dimensions is greater than number of samples. For our decision function, SVM is somehow memory efficient if we are using a subset of our training data. Not all the time memory efficient, but for smaller data sets it will be perfect. When we have large data set, SVM will be a poor choice because it will take a very long time in training. Imagine that SVM can be trained in a time that is much more higher than neural networks. If we have so much noise in our data, SVM will be a very bad choice. In cases like dealing with IoT data or sensors data, SVM will be a very bad choice because it's affected greatly by these noise points. Another problem with SVM doesn't provide probability estimates for our classes. So you can tell that this point may be of class A by a probability of 70%, for example. You can just know it's class A or class B, no probabilities. And the process of coming up with these probabilities using a cross-validation would imply training our algorithm more and more and come up with the average value of the appearances of our algorithm in each of these validations, and that would be memory inefficient and it would take a very long time in training. SVM can be used in many applications like face detection. It can be used in text and hypertext categorization, especially text, because text data is that kind of data that is connected to each other. Every word is connected to other word, so SVM can do perfectly in text data. It can be used in classification of images, in some bioinformatics application, and some application in handwriting recognition. Also in some predictive modeling, SVM can do well. So thank you.